Hello and welcome to Embed Logic's Knowledge Hub. I am Milind Trivedi and in today's video we will learn about real-time systems, non-real-time systems, their differences and application examples. So let's get started. Please note that we are not discussing about real-time operating system called RTOS. RTOS is a piece of code called operating system for embedded applications just like Windows or Linux for desktop applications. Instead, we are discussing about real-time and non-real-time system, which are actually classification of applications or systems based on how it handles tasks and processes based primarily on response timing and deadlines. Let's look at the real-time system. A real-time system is one that must respond to inputs or events within a strict time frame or deadlines. Keep in mind that it does not mean the system should be as fast as possible. It's a misconception that real-time systems means a super fast system. It means that system response time should be precise and deterministic and should provide the output exactly when it is required, not before or not after that. The response could be required after microseconds or milliseconds or seconds or any other time, but the deadline should not be missed. The correctness of a real-time system depends not only on the logical correctness of the outputs but also on the timing of these outputs. Even if system provides correct outputs but at incorrect time, it is considered as an incorrect outputs. For example, pacemaker has to provide electrical pulses and those pulses must be sent at correct intervals. If timing is not correct, the pacemaker is faulty even if it provides the pulses. A real-time system further classified into hard real-time or soft real-time based on how strict the timing constraints are and what could be the consequences of missing the deadlines. A system is called hard real-time if missing a deadline results into catastrophic failure and meeting deadlines is absolutely critical. Failing to respond within a specified time frame can result in several consequences such as system failure, damages, or even loss of life. Let's look at few examples of hard real-time system. Car airbag opening system is a classical example. In case of an accident, car airbag must open within few milliseconds. If it fails to open within the time frame, then the system is considered as a failure and there could be a loss of life of a person. Similarly, air traffic control systems must react to real-time data and make decisions about flight paths and landing sequences. Missing a deadline, like providing a clearance for a plane, could lead to accidents. And as discussed before, a pacemaker monitors the heart's rhythm and must deliver electrical pulses to the heart within a very precise time frame. Missing a deadline or failing to provide pulses when needed could be life-threatening. Let's check the meaning of soft real-time systems. Soft real-time systems also have time constraints and deadlines, but not as strict as hard real-time. If system misses a deadline, there would not be any serious consequences, but performance will be degraded and it can impact user experience. For example, multimedia streaming. You all know when you stream the YouTube or Netflix, you watch the videos, then it should be without interruption, it should be smooth. If there is a delay like buffering, the user may experience a temporary pause or lag, but still it does not cause any damage. Similarly, in online gaming, if there is a slight delay or lag in the data transmission, the game might experience some stuttering or players might be temporarily out of sync and the gameplay will not be smooth. Multimeters measure the quantity and display it. There could be some lag which is acceptable, like shown in this video. It displays the voltage in less than 1 second approximately. You can observe when I connect the lead, it displays the voltage. There is a slight lag of 1 second, but it's still acceptable. It would also be okay if it takes few more milliseconds as it can only impact my user experience. But what if this meter displays the quantity after, let's say, 10 seconds? Then nobody would want to use it, and that proves that this is an example of soft real time where timing is important but not too much strict. Finally, let's understand about non-real-time system. In non-real-time systems, the correctness of the operations is not dependent on strict timing constraints. In other words, these systems do not require a fixed or a guaranteed response time, They are not designed for that. Their functionality is correct as long as their system operates correctly, regardless of how long it takes to complete tasks. For example, desktop applications like word processor, web browser or video editor, etc. We cannot predict how fast word processor can open or how fast a video editor can finish editing. It can be within a second or it can take several seconds. Periodic data logging system logs the data periodically for analysis and storage purpose. There would not be precise timeline to take the data or there would be irregular log interval, but it should be fine as long as it logs it at some intervals. Similarly, home appliances like washing machine or oven also comes under this category because for proper washing, drying can happen without any time constraint. They are not designed by keeping the time in focus to get the desired level of washing or cooking. So that's all about real-time and non-real-time systems. I hope you like this video. If you have any question, please write it in a comment section. Like, share and subscribe the channel to view all the upcoming videos. Thank you and goodbye.